Hi friends, so by now we have got idea what is unit and what is dimension. So let's review it a bit by taking one example. Okay, so if I am adding 5 meter to 4 kilometer, first of all understand, can I add these? One is having a unit of meter, other quantity is having a unit of kilometer. So do you think I can add these two? Yes, I can add these two because they represent the same entity. They are having same dimension, which we have seen in the previous part one, in which we were adding 4 meter per second to 36 kilometer per hour. But we later converted the 36 kilometer per hour to meter per second. But we added them because they were having same dimension. So from there we got idea what is dimension. So in a similar way, we can also add 5 meter to 4 kilometer. So if I write 5 meter plus 4 kilometer equals to 400,500 centimeter. Okay, yes, see, okay, fine. So this is correct. So I have used meter, kilometer and centimeter in the one equation itself. So do you think it is correct? Yes, probably it's correct. Not probably, actually, it is correct. I mean, there's no problem. I mean, we can obviously use different units as per our choice, but all the things which we are using in the equation, they must represent the same entity. They must have same dimension. That is the must condition, and which it is following. So though actually in reality we never write equation that we are adding different units, we are using different units, one in meter, kilometer and centimeter, foot, pound, everything in one unit. But if someone want, they can do it. There's no problem in it. So as long as we are measuring the same physical quantity, we should not have problem. But you can see all the physical quantities or these things, or these parts, they are having same dimension. They are having different units but same dimension. So now you understand that the physical quantity, like these three things, they are representing length, they are having same dimension. They are having one dimension only. They are having one dimension, but they have many many units. So this is the difference, that they are having one dimension but they are having many units. It is possible, very much possible. So a physical quantity like speed or length or mass, they can have different units, as we have seen and we are going to see in future also. But they are going to have one dimension only. Fine, so you've got idea. Let's take another one for for your satisfaction. Do you think I can add 3 kg to 18 grams? Is it possible? Yes, it's possible because again, though the units are different, but they are representing the same entity, which is mass. So that is very much possible. And if I write the result in gram, that is also acceptable, because this quantity, this quantity, this quantity, they are having same dimension. They all are having same dimension. So it is not at all a problem for us. So you have got idea how important this dimension is. Okay. Let's move on and talk in more technical way. We all have seen this equation as equals to ut plus half at square. We all have seen this equation. In this equation, if I see s is in s represents length, it is in meter. The u, this part, u is the velocity, t is time obviously, so your velocity is in meter per second, time is in second, so again it is meter, acceleration is in meter per second square, and time square second square. So again this quantity comes out to be in meter. So you even in this physical equation, equation of physics, if we see all these three entities as ut and half at square, we can add them because they are of same kind, or in other way we can say because they represent the same dimension, they are having same dimension, that's why we are able to add them. Okay, but this is a physical this is something which is a equation of physics, so they are having same dimension and we are talking about dimensions and all those things. But in a real world, if you go to any shop, and you purchase two pencils, uh, three chairs, and you add them and you say five. Come on, how can you add two pencils to three chairs? I mean, that is completely absurd, but still you are saying five object. Fine, you are saying five objects, so that is practically acceptable because this is a mathematical rule which you have formed in your mind, that you are adding two pencil and three here which were object, and those two and three they made five, so it is acceptable. Suppose if I say 11 plus 3 is 2, you will say, come on, you are so crazy. But actually 11 plus 3 is possible. I mean, in real life. Okay, you must be wondering how it's possible. Have you seen a clock? If I say 11 o'clock plus 3 hours, that's going to give me 2 a.m. or p.m., depending on the depending on which part of day you are talking about. So that is again possible. I mean, though 11 plus 3 it never becomes 2, but these are the mathematical rules which we have formed in our mind, and this is mathematics which are made by human, but the physics, it doesn't work according to human. Physics is nature. Nature doesn't work according to human, it is already made, but we are trying to explain the nature using art formulas and things. We cannot change the formulas according to us. That is something which we have to see. So I think you have got idea that the dimensions are important in physical equations, but in real life, if we are making some other rules, that is also acceptable. Got it? So let's study something called principle of homogeneity. The principle of homogeneity. Let's study with some example. This is some physical quantity, this is plus minus, this is some physical quantity equals this plus minus this plus minus this, and so on. So if I see the principle of homogeneity, it says that in an equation, if we are adding or subtracting physical quantities in equation or formulas, they must have same dimension. I mean, the dimension of this quantity and dimension of this quantity, they must be same. This is what is said by principle of homogeneity. I have written this principle of homogeneity in this slide also. So you see principle of homogeneity, it says the quantity being added, let me use on a highlighter, that is much better to you for us. Quantities being added must have same dimension in any equation or formula. So you have got what this principle of homogeneity is saying, that if you if there is a equation, if there is a physical equation which is representing anything, maybe speed or speed, distance, time, whatever it is, if different quantities are being added or subtracted, they need to have same dimension. It is must condition, and this is what is principle of homogeneity. Fine, but now I'll say this is just a necessary condition. This is a, what I'm saying, this is a necessary condition. This is a necessary condition, but this is not enough. So why it's not enough, that we'll see. What I want to write, this is a necessary condition that dimensions of all the participating members in the equation and formula, they need to have same dimension, but it is said by law of homogeneity, or we can also say that principle of homogeneity. But now I am saying it is necessary condition but not enough condition, but not enough. Why? Do you think, let's take an example, do you think you can add velocity to speed? If I add velocity and speed, can I do that? Speed is having a dimension, same dimension. This is also length per unit time. The velocity is also length per unit time. They are having same dimension, but can we add them? Exactly, actually no, we cannot add them. Reason is, velocity is vector, speed is scalar, so obviously we cannot add them. So though the dimensions were correct, the dimensions were same, but they represent different physical quantities. In the similar way, if I take impulse is force into time, and if I make another physical quantity from on my own, which is mass into speed, these both the quantities, they are also having same same dimension, but this is again vector and this is scalar. So again I cannot add them because they still represent the same different quantities. So I think now you've got idea. Even if the dimensions are correct, you need to see that both the quantities or all the quantities, they should represent the same. They should represent the same physical quantity. But for now, in this chapter and in the principle of homogeneity, we are only going to study that in the for life, quantities are getting added or quantities are getting subtracted in formula or equation. They must have same dimension. Fine. So I think you've got idea. So now we can also say that different quantities having same dimension. If I talk about an equation, all the quantities can be added. All the quantities can be added and subtracted because they are having same dimension. But all the quantities which are having same dimension cannot be added or subtracted. We have seen that these two are having same dimension, but still we cannot add them or subtract them. These two are having same dimensions, but still we cannot add them, subtract them. So the reverse is not correct. Reverse of what means? Reverse of like in equation. We in an equation, all the participating members, they are having same dimension, and we can they are when we are adding the different members, they are having same dimension, but different members which are having same dimensions cannot be added and they cannot be formed they cannot be used to form an equation until unless they actually represent the same physical quantity. So you have got idea what is a principle of homogeneity in a very proper way. But I can tell you that the different physical quantities, they can be multiplied, though they cannot be added or subtracted always, but the different quantities having different dimensions, they can be added, multiplied or divided. They can be multiplied or in fact divided. So we can multiply mass to acceleration, we can multiply mass to velocity. Yeah, practically it is, everything is acceptable. Different physical quantities, I can write different physical quantities. Different physical quantities can multiply or divide. That's not a problem. But in addition and subtraction, we need to take care. Different physical quantities can multiply and divide. That is acceptable. So okay, let me know. I missed one more one example in which I had to take torque and energy. Torque is a vector quantity having unit Newton meter. Energy is a scalar quantity having unit Newton meter. They both are having same dimensions, but again we cannot add vector to scalars. We cannot add torque to energy. This is again not possible because they are different physical quantities. But as I told, the law of homogeneity or principle of homogeneity, it only talks about same dimensions. It doesn't talk much about different having same physical quantity. It is only concerned that in a formula or an equation, the different members must have same dimension. So as I have told that two different quantities can be multiplied or divided. So if I from there I get idea that force is written as is written as mass into acceleration. So if I have to calculate the dimension of force, since see, humans are quite lazy, even I am very lazy, so I have made one notation of my own. I enclose the force in bracket. This bracket shows that I am talking about the dimension of force. Dimension of force is going to be equal to dimension of mass into dimension of acceleration. In the similar way, if I write force is g m1 m2 upon r square, so dimension of force is going to be equal to dimension of g into dimension of mass m1 into dimension of mass m2 upon dimension of r square. If when we are going to calculate in future, both the dimensions they are going to be same, because the force because the same physical quantity is obviously going to have same dimension. So it makes clear the principle of homogeneity, and the discussion of unit and dimension, the basic discussion of unit and dimension ends here. So in next sessions we are going to discuss some questions, and we'll find out the dimensions of various quantities. Thank you so much, friends.